Hello and welcome to the Kubernetes podcast from Google. I'm your host, Caslin Fields.
And I'm Abdel Sigiwa.
This week we spoke to Bill Mulligan. Bill is a community pollinator at Isovalent and works on Cilium and eBPF. We learned how to properly pronounce Isovalent and what it actually means. We also spoke in depth about eBPF, Cilium, network function in Kubernetes, and more. But first, let's get to the news.
The legacy Linux package repositories, apt.kubernetes.io and yum.kubernetes.io, aka packages.cloud.google.com, have been frozen starting from September 13, 2023, and are going away in January 2024. If you run your own Kubernetes clusters, you must make sure your clusters are set up to pull from the active community-owned repository, packages.k8s.io. Make sure to check out the blog from the Kubernetes community in the show notes to learn more.
Kubernetes 1.29 is now available on GKE in the Rapid channel. Google Cloud customers can start experimenting with the new version of Kubernetes to find any backward compatibility issues that might occur.
VMware announced that Tanzu application catalog is fully compliant with the supply chain levels of software artifacts level 3 security, or SALSA. The application is the enterprise version of Bitnami app catalog available on the Tanzu platform.
AWS announced the pricing for extended support of Kubernetes minor versions on EKS. Starting April 1st, 2024, EKS clusters running versions in the extended support window will be charged 60 cents per cluster per hour. Clusters in standard support remain at 10 cents per cluster per hour. Extended support is a feature of EKS, which gives customers an extra 12 months of support for minor Kubernetes versions. In other terms, if you run in the extended support window of EKS, you will pay more for the support provided by AWS.
The Kubernetes Contributor Summit Paris will happen on March 19, 2024. The CFP for planned sessions is open to contributors and will close on Sunday, February 4th.
The agenda for KubeCon and Cloud Native Con co-located events is live. You can start building your agenda today for the 15 events happening on Tuesday, March 19th, 2024 in Paris.
The Cloud Native Glossary is now available in French. The glossary is a CNCF-led project that aims to explain cloud native concepts in simple language and is translated into 12 languages beside English.
Blixt, which means lightning in Swedish, however it may be pronounced, is the name of an experimental layer 4 load balancer for Kubernetes. The project originated at Kong and was donated to Kubernetes SIG Network in 2022. The control plane is built on the Gateway API using Go. The data plane uses eBPF and is written in Rust. There's a new blog post about Blixt from the Kubernetes community, which you can find the link to in the show notes. And that's the news.
Today, I'm with Bill Mulligan. Bill is a community builder at Isovalent, which I am going to count on you to tell me how to pronounce it, actually. And you're also a committer to Cilium. You run a very popular newsletter on LinkedIn, which I'm subscribed to. It's called Eco News, which is a biweekly publication on everything eBPF and Cilium. Welcome to the show, Bill.
Thanks for having me.
We were chatting before we started the recording, and you are from Wisconsin, right?
Yeah, that's correct.
Tell us something fun, something people don't know about you.
Yeah, so the big stereotype about Wisconsin is that it's like the biggest producer of cheese in America. And I guess the fun facts that I have is at my high school, we had drive your tractor to school day.
Okay.
And my uncle owned 8,000 cows.
Wow.
So all the stereotypes are true.
Okay, that's sure. I didn't say anything. You said it, right? So, all right. I've never been to Wisconsin. I hope I can visit at some point. So all the stuff I know about Wisconsin are American stand-up comedians making fun of Wisconsin.
Yeah, pretty much.
And cheese is one of them. So, all right. So, okay, cheese aside, let's get going. So we're here today to talk about eBPF, which I'm actually very excited to learn about because it have been a big subject of discussion / debate in the cloud native community. It's like one of the reasons why I actually wanted to have you on the show is to have somebody who could really make us make sense of all these technologies. But before we get going, tell us a little bit, how did you got into cloud native? Where does it all started?
Yeah, so my background is probably a little bit different than a lot of people in the industry. I actually did my undergrad in biochemistry, and then I did a master's in social science. And I would say I kind of accidentally fell into cloud native. I was looking for a job after grad school and, just applying to a bunch of different startups because that's, the people that employ people who have no other skills. And so I got into this 4-person company that was doing a machine learning platform on Kubernetes. And I was really excited because I thought Kubernetes was like some great Greek island and that's where like the company office were going to be. But then the first day at work, they sat me down with my Windows laptop and they're like, you're going to set up a Kubernetes cluster. And this is like Kubernetes 1.8 or something. And so I'd never seen the command line before. And yeah, it took me 8 hours, but I had a working Kubernetes cluster by the end of the day.
Nice. It sounds like your origin story is kind of similar to mine. My first job, my interview was set up a ticketing system based on OpenTickets, which is like an open source ticketing system, and then OpenERP, which today people call Odoo, which is like an ERP thing, right? So it was like, hey, sit down. If by the end of the day you manage to figure this out, you have a job. So it was interesting. Then you fall into it, and then how did you started like contributing to open source? What was your what do you do with open source stuff?
Yeah, so I think this is also funny for me. My first contribution was actually just fixing a broken link in the Kubernetes documentation. So Kubernetes SIG Docs does a lot of great work, I think, by getting people into the community. Even if they don't stick around like me, I made that contribution. And then I think I've made one other contribution to Kubernetes, but haven't been back since. But now I'm a maintainer of another project in the cloud native ecosystem. So from the first small change of just fixing a broken link to a maintainer. And I think it's great when people start small with open source. You don't need to, try to boil the whole cloud native ocean.
Yeah. And you certainly do not need to start contributing code, right? Documentation is a very good way to get started.
Yeah, absolutely.
I would even go further and say it's a very welcome contribution because I don't think a lot of developers actually like writing documentation. So if you are able to help out, people will appreciate that.
Yeah, definitely.
Awesome. All right, so then I guess you worked a bunch of companies before Isovalence, where you are right now, which is very known for A, having a very hard name to pronounce, and probably no one understands what it means, and B, pushing very hard on Cilium and eBPF. So let's start with the beginning. How do you pronounce the name of your company?
I'm actually very impressed with your pronunciation. I would say isovalent, which is very close to you. I've also heard isovalent and other iterations, but yeah, isovalent.
Okay. I guess probably the people who would say isovalent are maybe French speakers because ISO in French is written ISO, which is like the standard, right? Like the ISO plus a number. But I speak 2 other languages, so that's probably why. And I think I heard it pronounced before in a conference. So that's probably how I know it. So what does actually isovalent mean? Like the word?
Yeah. So the company actually wasn't originally named Isovalent. The original name of the company was Covalent. And this comes from chemistry, actually, when you have covalent bonds. And this is bonds between 2 atoms that are like really strong. And actually, if you look at the original Cilium logo, you kind of see this kind of covalent bond in the logo. Now, the project logo and the company name have been updated. So isovalent is very similar. You can also have isovalent bonds. And so that's where the pronunciation comes from too. So it's kind of this chemistry background of how do we connect things together, right? And that plays into everything that Cilium does today is really connecting our cloud native infrastructure.
Makes a lot of sense. All right. That means for the people who are going to transcript our episode, they will have to get it correctly. And then for us, we will have to go do some digging to find some chemistry Wikipedia pages to add to the show notes so people understand what you're talking about. Cool. And so since I joined Cloud Native, eBPF have always been in the picture. And the only thing I know is eBPF comes from something that was called BPF before, without the E, which stands for Berkeley Packet Filtering, which was supposed to be a replacement of IP tables. I might be wrong. So what is eBPF? Like, help us get the 101 kind of level of understanding.
eBPF is this Linux kernel technology. And what it allows you to do is to run essentially specified programs in the Linux kernel when certain event happens, right? So that's like kind of like the very, I guess, low level explanation of what eBPF is. Taking it up a level, the thing that a lot of people like to do is eBPF is to the kernel what JavaScript is to the browser. And so that kind of example you kind of get, right? before we had static web pages, and then JavaScript comes along. Suddenly we can have interactive elements that, kind of respond to user input. And that's a little bit what eBPF is doing into the kernel. An event happens, and then you can run a program that changes what's happening in the kernel. And then taking up one more level, kind of a really more abstract analogy that I sometimes like to use is kind of like eBPF is like the cloud native app store, right? So cell phones originally, when you had your brick phone, came with whatever software or programs were delivered by the device manufacturer, right? Then Apple came along with the iPhone, and there was an app store, and you could download new programs to add functionality on the fly for whatever you needed, right? So you're like, okay, I need to navigate around where I am. So I download Google Maps, right? I need to order food. I download Deliveroo, right? And so you can add new functionality to this existing hardware as you need it on the fly. And that's what eBPF allows you to do. You're adding new programs, new functionality to the Linux kernel when you need them, and you're able to run them, update them, and do this all in a safe, secure, and performant manner.
Awesome. I really like that analogy, actually. I really like the analogy of the browser. JavaScript is to the browser what eBPF is to the kernel. But let me get this in my own words. So when you say events, that's essentially in kernel terminology, that's syscalls, right?
Yeah.
Or that's things that the programs or apps running on the kernel are trying to do.
Yeah, exactly. So syscalls could be one example, or different trace points within the kernel. So whenever different things happen within the kernel. Yeah.
Got it. And then is eBPF more the framework and the runtime sandbox type thing, or is it just one of those things?
eBPF is actually made up of a lot of different components. And I would recommend checking out eBPF.io. It has an explanation of what eBPF is, but essentially kind of walking through what it is. First, you're going to have your eBPF program, and eBPF programs are written by developers. These are then going to be loaded into the kernel, usually by a library. So for example, Cilium has an eBPF Go library that we use. The kernel is then going to go through a process of verification. And this verification step is actually really important for eBPF because it essentially ensures the safety of the Linux kernel, right? This is kind of like the critical component of your operating system. So you want to make sure it doesn't crash or stall the kernel. So the verifier makes sure that the program's run to completion, it's not accessing memory it isn't supposed to, essentially that these programs are going to be safe for your Linux kernel to run. Then it's going to be JIT compiled to the architecture. So it basically runs as fast as natively compiled kernel code. And then it's going to be essentially loaded into your kernel, right? And so then it's a sandbox program running it into the kernel. But the great thing about eBPF is it provides a really low overhead way of doing this because this program isn't just something that's running all the time, running in the background, right? It's only running essentially when it's a specific event that triggers it happens.
Yeah.
And so you have these really low overhead way of doing new things in the kernel, right? And since it's running into the kernel, it has access to a lot of things that aren't available to programs just running in user space too.
Got it. Yeah, so that's a very, very good explanation in the sense that basically whatever the kernel executes, you can hook up kind of like a program to it and then make the program do certain things for you, either modify things or maybe even observability. I know that's one of the features of Cilium is observability, which relies on eBPF. And then you can go you can get some super fine-grained observability that you cannot get from, let's say, the HTTP stack or the TCP stack or whatever, right? Okay, so that's cool. So then that's basically explaining what's eBPF. But what is eBPF today in 2024? I guess what my question is, help people make a sense of as a developer, should I care? Shouldn't I care? Will I ever have to use eBPF? Will I ever have to use there is a library that uses eBPF? Is this something that people have to be exposed to? Or let's say, I don't know, 99% of people, we shouldn't care?
So I would say it's both. And okay. like any good answer, it depends. So what eBPF is in 2024, and maybe I'll start with first, why are people talking about it so much and why has it become a hot technology right now?
Cool.
And kind of when we're thinking about like the cloud native revolution. Things are happening a lot faster. They're a lot more dynamic. And we need to kind of essentially design infrastructure for a different scale, a different speed than we were doing previously, right? It's kind of like this whole also like pets to cattle analogy too, right? We're using from things that we can maintain individually and by themselves to, kind of like groups of things. And so what eBPF allows us to do is to add new functionality, because what people may not like realize about the Linux kernel is that, it's a 30-year-old technology and it's kind of accumulated a lot of things in 30 years. And the other thing is Linux is deployed on literally billions of devices worldwide, right? And so if you want to make a change to the upstream community, you have to get it accepted by the whole community, and it has to be acceptable to run on those billions of devices, right?
Yeah.
And so since it's such a critical component of basically all modern computing, it takes a long time to bring things into production. And so if you have an idea of like, hey, I'd like to add this new functionality to the Linux kernel, first you have to convince the Linux kernel community that's a good idea, get it merged upstream. And then once it's merged upstream, it's in the latest Linux kernel release. And to get it into a long-term supported release by your vendor or that you're using or that's approved by, compliance, that may take actually a couple of years. So this new functionality isn't something that you can have tomorrow. It's something that can take literally a couple of years to actually reach end users. And eBPF really changes this whole paradigm, right? You can sit down, like write an eBPF program, adding this new functionality, load it into your kernel on the fly, making with eBPF verify ensures that it's not going to crash your kernel. And once you have this new functionality in your kernel, you're able to change essentially what the Linux kernel is doing. And Brendan Gregg, who is a person who popularized a lot of stuff around eBPF, gave a talk at the last eBPF summit about Fast by Friday. And he's talking about how he could literally be in meetings with customers and they were asking questions about the performance of their systems. He could write an eBPF program in the meeting and show them the actual data by the end of the meeting, right?
Wow.
That's the difference, like days, hours, rather than years. And I think that's why eBPF is becoming so important and interesting right now, because in the cloud native world, things move quickly and eBPF allows us to keep up with that speed of change. And I guess the real question is like whether you should care about it. Should everybody go start programming eBPF programs tomorrow?
Yes.
And this, I think, also depends too, like any good answer. But I think the answer for most people is actually probably no. I think this may be a little bit controversial, right? People like to get their hands on with the newest, the latest technology. But the same thing that we were kind of like seeing with Linux kernel development before, right? A lot of specialized companies, people like Google, deploy a team of Linux kernel developers so that they can make the modifications that they need, right? And, maybe even maintain their own kernel. But like most companies are going to take either a regular release from like one of the distributions or like run something from their vendor of choice. And that's because they don't have kind of like this expertise to be able to do that. But they're still using Linux as this underlying technology that they're relying on. And I think we're going to see the same thing with eBPF. People that are really specialized in this are going to be writing eBPF programs. It's going to be providing a lot of functionality, a lot of benefits in terms of performance, scalability, time to market. But in terms of like actually programming eBPF, most companies aren't going to have to worry about that. And I actually think in some ways that's a good thing, because you get the advantage of this technology without having to become an expert in it.
Got it.
Right? And that's kind of what we like about advanced technologies. There's the quote, like, any sufficiently advanced technology is indistinguishable from magic. And I think that's what eBPF is going to provide to a lot of people, right? This magical experience of getting this new functionality in their Linux kernel, like providing something like faster networking, better observability, more secure systems, essentially tomorrow for free, right? And that's a great benefit. And they don't have to know how it works all under the hood, but they still get the benefits of this technology.
Got it. But that's good. And the analogy or the example I would give here, and I'm realizing I'm going to give a product pitch, but whatever. It's the GKE data plane 2 version 2, which we talked about on Twitter, right? Like the new functionality we added where we replaced the old CNI we had in GKE with Cilium, and we were able to instantly give people a network policy login, right? because before network policy couldn't debug it because there is no logs. And so now we just added this new functionality. And for most people, they shouldn't care that it's there. They just need to know, okay, well, you annotate your network policy and then boom, we can generate logs for you. And that helps further debugging or troubleshooting if network policies are actually working or not working, right? Because I know that one of the probably big things in Kubernetes is that no one really likes how network policies are written. They are really a pain to write and understand, right? So that's a good way to describe it in the sense that a lot of people will just have to install something, enable something, and in your analogy you used, download an app from the marketplace, and then boom, they have the functionality without having to even care about it.
Yeah, exactly. It's like the same way you don't care what language your app on your phone is written in, right? People aren't going to care like whether something is written with IP tables or eBPF. They're going to look for the actual like end user benefits. Does this provide me faster networking? Is this easier to debug? And I think projects and products that are leveraging eBPF are going to eventually win out in the end because of these benefits that essentially come with eBPF itself.
Awesome. Cool. Then, okay, we'll move forward toward the other thing that your company does is Cilium, right? So I went and scooped around a little bit in the Isovalent website and, clicked on the products, and there's like a long list of functionalities that Cilium can do. In my head, and again, maybe I'm too dumb to follow up, Cilium is a CNI. That's how I know it. So what is Cilium today? What can people do with Cilium?
Yeah, so if you go to cilium.io, you'll see the headlines and it says eBPF powered networking, observability, and security. And that's what it does. Networking, security, observability, which are obviously all really broad buckets. But I think
yes,
kind of if we dive into each of those, we can kind of trace the history and the development of the Cilium project and kind of understand how it came to be and why it is the way today. So you're right. Cilium originally started just as a CNI. So a way to connect containers together, right? And that was back in 2015. I think one of the things that a lot of people maybe don't realize about Cilium is that it's actually quite an old project at this point. It's going to be going on 9 years now.
Yes, it's 1 year younger than Kubernetes itself.
Yeah, exactly. So it's been around for a long time and kind of seen a lot of developments, right? And I think the project has really grown with the needs of the cloud native industry as a whole too. And so it began first as this connectivity layer, connecting containers together. Then the next thing that people start to ask for is how do we secure this? This is where network policy comes in, right? If in a world of microservices, everything's flowing over the network. So we need to be able to secure this. That's kind of where the first part of security comes into. Then the next part is around observability. If all of our traffic is flowing over the network, what happens when things break if we need to debug something? And this is where Hubble was launched. And Hubble provides you network observability. Basically, what it does is it attaches onto Cilium, pulls all the kind of information off of Cilium so that you're able to see things like a service map. You'll be able to pull network metrics out of there and have observability of, is this thing connected or is it not? Right. And then as we see kind of the development of the industry from single clusters to multi-clusters, Cilium added things like multi-cluster mesh, being able to provide a consistent layer to tie everything together. And then I think now we've gotten to a point in the industry where cloud native really isn't just about Kubernetes. It's about being able to extend to things outside of Kubernetes too. And so this is when we started to get things like Cilium Mesh, so providing transit gateways to virtual machines, bare metal machines. And then I think mesh is a very overloaded term, but there's also Cilium Service Mesh, which kind of does this exact same thing, connecting, securing, and observing everything. And I think a lot of people tie service mesh with these terms too, but I think different from a lot of service meshes, Cilium kind of goes from the bottom up, from layer 3, layer 4, controlling all of the network packets, up towards layer 7. And I think that's the thing that's exciting for me about Cilium Service Mesh, is really connecting, securing, and observing everything that's happening. And in, I guess, the world of distributed computing, everything's going over the network. So it really is the most critical layer in your infrastructure stack today.
Yeah. I think it's important to acknowledge, as you rightfully mentioned, that service mesh is an overloaded term. And that's probably because Istio was the first open source project, to introduce this concept of service mesh. In people's head, it just stuck with how Istio does things. But that's not necessarily the case for other service meshes. I remember looking at Linkerd. I looked also at, not Cilium, but I looked at the other one. There is one which is open source, very popular. At some point, HashiCorp released their console service mesh. So I was looking at those and I was like, realizing, okay, well, the way the service mesh architecture in Istio is very specific to Istio, and that's not necessarily how all the other tools doing service mesh work.
Yeah, I would say this is actually like a really funny thing about like Cilium Service Mesh. Cilium Service Mesh, when we kind of were thinking about it and we looked around, what does a service mesh mean today? Like, what are all the functionalities? And the Cilium project itself, like before we launched the official Cilium service mesh, already had, kind of 80% of the functionality of a service mesh. Things like connecting things together, connecting multiple clusters together, providing that observability component, providing some type of, like network security too, right? And there's only a couple things around like mutual authentication that were actually added to make it the official Cilium service mesh.
Got it.
I'm kind of biased here. I've like written some articles that I think in the future, we're actually going to see like the whole service mesh terminology just kind of disappear, right? Because these are things that we were doing before, like connecting things together, observing how they work, providing security for them, right? These are all part of the networking layer itself. I don't think it needs to be a whole separate like category. It's part of what we do, we're already doing. I think we originally came up with the service mesh term to help us understand these for like the cloud native world. But as we've, kind of advanced so much in the past 8-9 years, I think we've learned a lot and we're able to take those learnings and integrate them back. And I think this is a really important thing if we want to move the industry forwards, because I think at this point we've seen Kubernetes has a lot of mainstream adoption, and we need to, it's not kind of the new use cases is connecting back to the rest of our IT infrastructure. And a big part of that is educating and helping other people understand how their world connects to the cloud native world. And we need to be able to translate that terminology from cloud native back into the rest of our infrastructure. Some people in the networking world, this is people who are working with hardware switches, the Cisco switches, right, are doing things with BGP. How do they connect to the cloud native world? Well, we need to explain things in their terminology. I think we're going to see a lot of that going forwards.
I don't think that you mentioning the fact that the service mesh will disappear as a term, as it probably will become like a native feature into Kubernetes itself, maybe going further. I don't think that that's neither a hot take nor a biased thing. I think that the way Kubernetes itself is progressing is going in a sense that a lot of things that used to be a big deal a few years ago now are just available in the platform and no one cares about them, right? And that's, in my opinion, one of the best things in Kubernetes as a project. It's being able to like provide you with that abstraction layer, that what you used to care about, I don't know, people used to care about jobs, and the job API was a big deal a few years ago. Now it's just there. Like no one cares, right? It's whatever. You just write a job, you write a cron, and it just works, right? So in that sense, service mesh not becoming a big deal and the functionalities just being part of the platform is, as you said, probably going to make it such a way that no one will care about service mesh at all in the future. And in that sense, I might be considering myself a visionary because I wrote that you probably don't need a service mesh talk a couple of times, which goes in this sense of like explaining to people that your CISO reading a white paper that says service mesh is a big deal. That's not how you should reason or think about it, right? You shouldn't implement it just because everybody is doing it. You should implement it because you know what it does. Cool. Well, that's just a long ride. Anyway, I wanted to move further to the next part of my question. So, eBPF and Cilium, how are they connected? And what's the relationship between these two things?
It's similar to what we were just talking about like kind of this abstraction layer, right? So I would say that Cilium in some ways is an abstraction layer on eBPF, right? So eBPF is kind of all these programs running in the kernel, but you need a way to manage that to do what you want to do. And rather than writing bytecode or programming eBPF program, Cilium allows you to write things in YAML, right? And so you can say, connect these two containers. This container shouldn't talk to that container. Tell me what our network traffic looks like in your YAML definitions, rather than having to write the eBPF programs. So what Cilium essentially does is there's a Cilium agent that's installed as a daemon set on every single node in your clusters. And what that's responsible for is loading and unloading these eBPF programs that are doing the networking, the observability, and the security in your cluster.
Got it. Got it. So essentially, Cilium uses eBPF for part of the features it's able to provide.
Yeah, essentially all of the features are like the vast majority of the features in Cilium are done through eBPF.
Got it. So does that mean that people would be able to probably, if they still want to have the option to write their own eBPF programs and run them as part of Cilium? Is there like an API to extend Cilium itself?
You can run eBPF programs on nodes that are also running Cilium. If you want to do different things or you want to collect different metrics than Cilium is doing. And we see people doing that right now. Mm-hmm. So I think one thing that's kind of interesting, Cilium was one of the first applications leveraging eBPF, and we're starting to see more and more of them. And one of the interesting things in the eBPF ecosystem is now kind of how do we manage all of these eBPF programs in a sensible and reasonable way. So similar to Kubernetes, it is managing the lifecycle of all these containers that are suddenly appearing on our infrastructure. I think in the same way, we're going to have to figure out how we deal with the whole lifecycle and, let's say, orchestration of these eBPF programs running on your Linux node. The kernel community is still like discussing how this is going to happen. I don't think this is a finished discussion. We're kind of at the start, not the end. But I think this is a really interesting area for the whole eBPF community right now.
Got it. Yeah. Now, at least I can confidently say I understand what eBPF and Cilium are. So thank you for all these explanations. That's amazing. So Cilium is now a CNCF project, right?
Yep.
At what level? Is it graduated sandbox?
Yeah, just graduated last year.
Graduated last year. Cool. So is Isovalent still one of the biggest contributors to it? Or like, are there other people? Because I know that there are other companies also offering managed stuff around Cilium, right?
Yep. Isovalent is the main contributor, and I actually have the annual report from Cilium. Every year we kind of do a summary of what's happened in the community, and you can link it in the show notes too. And the top 5 contributing companies by number of PRs were Isovalent, Independent, Red Hat, VMware, and Google. Okay,
cool. Yeah, because I remember that we mentioned the report in our last episode in the news portion.
Exactly.
Because I saw it on the CNCF website blog. But I didn't read the details. Okay, so you're still one of the main contributors. And okay, so then we talked about eBPF, we talked about Cilium, we talked about Kubernetes and the ecosystem and all this cloud native stuff. Then Isovalent is the company that provides managed offering around this, right?
So we provide a enterprise distribution of Cilium.
Okay, enterprise distribution. So it's like the freemium model. You have the open source, which you can use, but then if you need more features or technical support, you can go to Isovalent.
Yeah, exactly.
Cool. And I know that's one of the things that I have seen, and I also replied to one of the posts on LinkedIn was the CCA, which is the Cilium Certified Associate. For those of you who doesn't know, I consider certificates like Pokemons. I just want to have them all. So what's that? Like, are you involved in that project?
Yeah, so I've been involved in that project too. This is a new certification from the Linux Foundation, similar to the CK, CKD, KCNA, if you want to keep on going with the alphabet soup here.
Yes, the ICA, the ISTU one.
Yeah, exactly. So the CCA is a new certification from the Linux Foundation focused specifically on Cilium. And it's an entry-level certification, basically to test your knowledge. Like, do you know what Cilium is? Do you know like the different features and things like that? And so I'll just walk through the general like components of the exam so people can learn more about it. So the first part is installation configuration. The second part is the architecture of Cilium. Then it goes into network policy. So how do you secure your network? Service mesh, network observability with Hubble and the service mesh, cluster mesh, a basic understanding of eBPF, things like BGP and external networking. So it covers a wide range of different topics on there.
Cool. It's worth mentioning that as of now that we're recording this, the exam is in beta. You have to sign up to get it. I replied to Chris, the CTO of the CNCF, to say I want to be in. And I guess there was a conversation going on LinkedIn between yourself, myself, and then somebody also from Isovalent where we shared some resources around how to prepare for it, which we'll make sure to include in the show notes, right?
Yep.
Anything else you want to mention about the certification? Is it worth people time? Should people go look at it?
Yeah, it was done by a lot of people across the community. So lots of great questions. I know there's a lot of experts on that. I think a lot of it was driven by my colleague Nico, and he does a lot of great content around Cilium. Shedrack on my team also came up with a CCA study guide that you can find on GitHub. So I'd recommend checking that out. I'm sure it'll be in the show notes. And if you want to catch them all for certs around Cilium, I'd also recommend going to the Isovalent website. We actually have a lot of labs, and these are hands-on demo environments going through essentially all the different features about Cilium. And people really love them, and a lot of people are trying to collect them all. And my colleague Raphael also created a whole World of Cilium thing that will take you to kind of the different parts of the project, and you can do labs and track your progress on kind of going through the whole world of Cilium. So there's a lot of cool resources to check out if you want to learn more about the project after this podcast.
Yeah, awesome. Yeah, we'll make sure to include all the links. I see certifications beyond the Pokemon joke as just a great way to learn things and kind of stay on top of the game and also to test your knowledge. So I think it's worth it. So I just make sure to check it out. It's in beta. And also it's worth mentioning that when certifications are being developed by the Linux Foundation, they do actually use the community to help write questions. So if you're interested, there are ways to actually get involved in these things. Cool. So we're getting close to almost the end of our conversation here, but I still wanted to mention some news from, I think, late last year. You got acquired by Cisco.
We did.
It's funny that you mentioned earlier that you're trying to bridge the gap between cloud native networking and then the Cisco switch-based hardware networking world. I'm coming from that world, by the way, FYI. That's what I did in a previous life. So what's that? What does that mean actually for Isovalent?
I think it makes me more excited about the future for Cilium. I think in the cloud native world, Cilium has become the default option for all the major public cloud providers, basically every single Kubernetes distribution, literally hundreds of end users from all different scales across every single industry. Cilium has become the standard in the cloud native world. I think this acquisition by Cisco really signifies that Cilium is becoming the future of networking. I think Cisco as this networking giant saying, we think Cilium is the future, I think is a really big statement for where the project is heading to. And it's kind of looking around who hasn't said Cilium is the future for networking? And there's not that many people left. So it makes me really excited about the future of the project.
Yeah.
In terms of what does it mean for Isovalent, it means we have more resources, more people, more of everything to continue investing in the Cilium project. So I'm super excited about where the project is going. I know there's a lot of people over at Cisco, like Stephen Augustus, heading up the open source program office there, and they're looking to do a lot more in the cloud native community. And so I think this is a really exciting time to come in there and really build the momentum even more behind the Cilium project.
Yeah, it's as we were talking, actually, I was thinking in my head, before advocacy, I was doing consulting, and a big part of any migration project to the cloud, when you work with major companies that already have their on-premise systems and they're looking into either extending to the cloud to use more stuff in the cloud or just completely migrating, part of what we call the foundational job, the foundational work you have to do is disconnecting the cloud to on-premise, right? And I remember from that time when I didn't even knew Cilium existed, a lot of times it's discussions that are more tailored toward the old school, if I dare say it this way. It's VPNs and, routers and stuff like that. And I do see Cisco coming and acquiring a cloud native company is a very good indicator of the maturity of the project, and also probably an indicator of the future, if I dare make a prediction, that networking will just become easier. And it's being able to, because one of the things that Cilium does is it's YAML file based, right? So you just write a YAML file and then you guys wrote code that translates YAML file into low-level IPs and TCP sessions and firewalls and all that stuff that 99% of developers shouldn't even care about, right? So going further, being able to interconnect this traditional networking and cloud native networking is super exciting, in my opinion, future to look for.
Yeah, I think that's the future that we're looking at too. And it kind of goes back to what I was talking about before, is how can we make sure that we bring the rest of IT into, or at least connected to, the cloud native world? And I think this really positions us very well. And the Cilium project as a whole, kind of to be this bridge from cloud native to the rest of our IT infrastructure. And I think eBPF is becoming a key part of this too. My colleague Dan Finneran is doing a lot of fun stuff. I don't know if you've seen on Twitter. He recently did something about BGP in eBPF.
Oh, yes, I think so. Yeah,
yeah, and I think we're going to see a lot more fun stuff like that coming out too, to making sure that the networking does just work rather than, kind of debugging late at night.
Yeah. And actually, another thing I wanted to mention around eBPF, and if anybody is wondering I don't think that anybody should be wondering the question of how mature this technology is, because again, as we said, it existed for a while. But if anybody is still wondering, should this thing be a thing? Should you care? I guess the way I like to describe it is any technology, whenever the Java community starts caring about it, it's serious, right? So this context, a friend of mine called Mohammed Abu Lait and another person, I forgot his name, are actually writing a library for Java for eBPF, right? So they are making it available to use eBPF from Java. And that's once Java cares, it's serious, it's a big deal, right? So yeah, it's just, this is not a joke. This is serious, right? Because if there is any constant in technology time, Java it is. So that's the only thing that existed since probably most people my age, your age, and people around us have got into the technology space. Java was the first thing we heard. So yeah, if people at Java cares, that's a safe bet in terms of technology and careers, I guess.
Yeah, absolutely.
Awesome. It was a pleasure talking to you. Thank you for all the explanations.
Yeah, and thank you for having me. It was really a fun conversation with you.
Yeah, it's you helped us explain eBPF and Cilium. So now next time somebody asks me what eBPF is, I will just point to this episode and go listen to what Bill has to say.
Oh, perfect. Thank you.
Awesome. Thank you very much, Bill.
Yeah, thank you.
Thank you so much for that interview, Abdel. It's always great to hear from Bill. He used to work for the CNCF, if I recall correctly. And so I met him through that. So it's always good to hear from him.
Yeah, I think he had some marketing chair position within the CNCF.
Something like that.
Or was working. Yeah, I remember that from reading the LinkedIn profile.
Regardless, Bill is awesome, and you should totally follow the stuff that he does because he finds good things to be involved in my experience with him.
Definitely.
And we heard a little bit about that background in your interview as well. I didn't know that he had a background in biotech, which is something that I strongly considered going into, and then ended up in tech through startups and doing Kubernetes. Love it.
Yeah, it's quite interesting. We were debating before the interview whether we should make the joke about Wisconsin and where he's from. And then he was like, well, my uncle has cows. I was like, well, we should definitely talk about that then.
I mean, you gotta talk about it.
You gotta talk about it, exactly.
My family actually raises cattle as well.
Really? Wow.
Yeah, in Virginia, just as kind of a small time thing. But every time I go home, last time I went home, my dad actually smoked a brisket that was from one of the cows that my uncle raised. So that was pretty cool.
Wow. All right. Well, maybe it's actually my retirement project. So let's see.
Good luck with that. I'm not doing that. Back to Cilium, though, in eBPF.
Yes.
Something really interesting that I learned about Cilium from this is that it's only a year younger than Kubernetes itself, which I did not know.
Yeah, that's actually why in the interview I brought up this point of what is Cilium beyond just the CNI? Because it was introduced as the CNI in 2015, so 1 year after Kubernetes. But then it just kept growing, right? So that's why I made sure to talk about talk about Cilium outside of the CNI, and that's when we start talking about the service mesh and observability and all that stuff, right? That's
really impressive, and I'm surprised that it's that old. I can't believe that I didn't know that before now, but...
Yeah.
But it never worked in a realm that was not containers, it sounds like. Because things that early, 2015-ish and earlier, it's a lot of those types of tools worked for things before containers started to become a thing. But not Cilium. Cilium was geared toward containers the whole time, it sounds like.
Yeah, it was pretty much a Kubernetes and containers thing. I think over time, what's probably going to happen is, especially with the acquisition with Cisco, they'll probably start building up stuff that are, in the interview, Bill talked about connecting, your on-premise systems to your cloud native systems. So in your on-premise, you don't necessarily have containers and Kubernetes, so you might need to run stuff on VMs and things like that. So that probably would be the future because they're focusing quite a lot on this multi-cluster service mesh kind of thing, right?
Yeah, he mentioned that extensibility and I think he used the terminology of Kubernetes dependencies, which I have all sorts of things I want to talk about there, but he mentioned that was kind of the direction that Cilium was going in, which I find really interesting because I think that is a big trend. And I think you mentioned that in the interview as well, that like Kubernetes over time has kind of gathered up a lot of these functionalities that were outside of it, but kind of didn't make sense outside of it over time. So it's definitely expanded to some degree. But I think that going forward, it'll continue to be a big thing around like the things Kubernetes interacts with.
Yes.
That is often kind of really the hard part of Kubernetes. The stuff within Kubernetes, if it has the functionality that you need, that's great. And there's a lot that it does. But at some point, you go beyond the realm of Kubernetes itself, and you need some additional tools to help you out. And so Cilium is kind of focused in that space, which makes a lot of sense.
Yeah. Before advocacy, when I was in consulting, Cilium was the number one tool that customers were asking about all the time, right? Way before even we introduced it to GKE in the form of data plane version 2.
Interesting.
So before that was the case, people were asking us, like, can we actually like buy Cilium Enterprise or buy the actual, enterprise support from Isovalent and just run it ourselves. And we do support it. If you want to run it, you can. Because people wanted those like extra functionalities.
Very interesting. And this kind of extension of Kubernetes of like, you get to a certain point in Kubernetes and you're like, I need these things. And Kubernetes doesn't provide that. Like, I used to talk about observability and a few like security things like MTLS and stuff. These are the kinds of things where I would talk about, here's service meshes, and they kind of fill these gaps. And you'll talked about kind of the relationship between Cilium and service mesh a bit. And I'm not sure that I totally understood it. So being new to Cilium, which now I'm like, how have I avoided Cilium for this long? And I need to fix that. But
yeah.
So it sounds like Cilium is kind of service mesh adjacent. Does it have its own service mesh thing? What is going on here exactly?
So the easiest way to think about it is the following. It has service mesh, but it's not service mesh that you might know if you think about service mesh in the context of Istio.
Service mesh is a broad field, huh?
Correct. One of the conversation was about the fact that it's an overloaded term because the term service mesh was introduced by Istio based on how Istio was architected to work in the first place, right?
Yep.
But the term itself is generic and it can mean whatever you want it to mean. So when Cilium came into the picture, and to their credits, they're not trying to compete. Like, they're not saying, oh, yeah, we're better than Istio or we can do what Istio does. They're saying, like, we do service mesh the way we think it should be done.
Yeah.
Which is pretty cool, right?
Overloaded term.
Exactly.
I remember in like 2018-ish when service mesh was the big thing that everyone was talking about. Trying to explain it was always a challenge. And it sounds like it's kind of like Sidecar. I just put out a blog post on Sidecar, which is a term that we use very frequently in the community, but it's just kind of a colloquial term, honestly. It doesn't have a specific meaning in the technology. It's just how we describe the pattern.
Correct.
And service mesh is kind of similar. It's the pattern, I guess, of extending Kubernetes.
Correct.
Really in a broad definition of ways.
Yeah, I think really you can think about service mesh as, again, whether it's based on sidecars or not based on sidecars, because Cilium is not. It's eBPF based, right? So there is technically no sidecars. But you can think about it as one way is to say, take the term service mesh and look at the mesh. What does a mesh mean? It just literally means that all your pods inside the cluster and potentially in various clusters, so multi-cluster setup, know about each other and they can route traffic between them all the time. Because in a non-service mesh scenario, we just use services of type load balancer, so the cluster IP, and then you have that virtual IP that you send requests to, and then it gets translated to pod IPs. In a service mesh world, the pods know where all the other pods are, right? So that's like one way of thinking about it. And then the second way is Kubernetes networking is pretty dumb. It's pretty basic. It's IP-based, so it's IP port. Service mesh adds those functionalities about observability, about, more kind of fine-grained network controls based on identities instead of like just a basic firewalling and stuff like that. So yeah, again, I think we probably need to do a whole episode just talking about service mesh.
Yeah. I mean, there have been several on the podcast before, but we should probably update some of that because it's been a while. I'd say that service mesh is not as big of a hot topic as it used to be, but it's definitely still around and people are definitely still using it a lot.
Yeah, we should do some service mesh in 2024.
That would be interesting. Yeah, I have some ideas for that. We'll talk about that later. But
yeah, sure.
A couple more things quickly here. One thing that I thought was cool was that Cilium essentially works by using daemon sets in Kubernetes.
Yeah, for the agent.
Yeah, is, I think, I kind of hesitate to use this term, but kind of a best practice in Kubernetes. A lot of the time, folks want to run things on the nodes in Kubernetes, and they run them directly on the node to have like root access to the node so that they can run, especially the kinds of things that Cilium does, the kind of observability and the kind of system level observability into your applications. And they'll run that directly on the node, which I tend to see as an anti-pattern because you don't want to be messing around with the nodes of the Kubernetes cluster as much as you can. You want to be staying within Kubernetes.
Yes.
So I think it's really cool that Cilium is eBPF, so it's at the kernel level, but it's still staying within the abstraction of Kubernetes as well.
Yeah, that's very interesting. I had to go after the interview and do some, snooping around the documentation to understand the architecture and stuff. So,
yeah.
But yeah, that's a very valid observation. It's interesting that they do the agent. I mean, it's not only the agent for Cilium itself, it's even the agent for Hubble, which is the observability stack of Cilium. That also runs as a daemon set. I have tried this on GKE before. It works, actually. It's pretty cool.
Yeah.
It gives you this like nice interface and tells you what's talking to what and, the amount of traffic and all that things.
I don't know if it works on GK Autopilot. I know at the beginning of GK Autopilot, Cilium did not fully work because Autopilot puts in several like security barriers and kind of forces you into best practices. And one of those best practices that Autopilot tries to force you into is keeping things at the Kubernetes abstraction layer. And so there are some things that are closer to the operating system, things that would require like root access or access to your nodes that could be dangerous that Autopilot doesn't allow you to do. And eBPF is one of those things that kind of skirts that line.
Yes.
Bill talked a little bit about some of the security features of eBPF to protect your kernel, but one of the biggest complaints that I hear, reasons not to use eBPF that I hear, is concerns about security, because anything that you're doing that's going to run things at the kernel level is, of course, going to be a little bit scary security-wise.
Yeah, of course. Yeah, so I tried Hubble on data plane version 2, so which is Cilium-based, but on standards mode, not autopilot mode. So I don't know if it works on autopilot mode. I would assume not, because I think the way autopilot works is that we have special partnerships with companies that have tools that, so they call them like security partners or something. There's like some certain things work that require privileged containers, but we have to explicitly allow them to work. It's like kind of the opposite of how standard mode works, right? I don't know about Cilium. I think we'll have to do some digging to figure that out.
Yeah, that's always kind of the trade-off, right? Is how much abstraction do you want versus how much control do you want?
Yeah, correct. Yeah.
Autopilot is one of those abstraction layers that takes away a bit more of that control, but it makes things a little bit easier to do and to do right, theoretically. So they try to put in some good guidelines, but Cilium will be one of those interesting cases that's like, we'll have to look into it.
Yeah.
Last thing, the beginning of the interview. What I learned about eBPF from this interview, I think the way that I would likely describe it to folks is it's a good way to be able to run things at the kernel level without having to get them into open source. I thought that was a really cool use case that Bill described.
Yes.
And so I feel like that's kind of the core of what it allows you to accomplish. What do you think?
Yes.
Abdel?
Yeah, I think that's a very good way of putting it. I remember that part from the conversation. And it's, if you want to extend Linux functionalities, it will take you ages to get that accepted by the community and contributed upstream. And eBPF allows you to do that relatively quickly. So that's a very good way of describing it.
I wonder if Linux maintainers have seen any impact on their workload from the introduction of eBPF.
I mean, I guess to a large extent, we can draw a lot of analogies between how Kubernetes work and how the Linux kernel work, in the sense that Kubernetes and Linux are trying to keep things under control, and they don't want to just like start accepting any sort of customization required. So what they're doing is that they're just building an abstraction layer. They say, as long as your thing talks this API, we don't care, right?
Yeah.
And I think Linux works a little bit like that, in the sense that here is eBPF, you can extend it by yourself or write code inside this thing. It's your problem. We're just going to give you the API, and that's it, right?
Yep.
So yeah.
There have been a lot of parallels drawn between Kubernetes itself and the Linux kernel itself over time.
I mean, it's the two biggest projects, open source projects, right? So
yeah.
So two very successful open source projects. So
yeah, so enormous.
Exactly.
Anyway, thank you very much, Abdel.
Thank you.
Yeah, we'll see you all next time. That brings us to the end of another episode. If you enjoyed this show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on social media at KubernetesPod or reach us by email at kubernetespodcast@google.com. You can also check out the website at kubernetespodcast.com, where you'll find transcripts and show notes and links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.